Hello students. Now, in the last session of satellite communication and networking, we have discussed two multiple access methods. First that was FDMA and second that was TDMA, right? And we have discussed what are the advantages, disadvantages and what are the different applications respected to that multiple access technique. Now, in today's session, we are going to start with another multiplexing technique, that is CDMA, that is the code division multiple access, right? So let's start with the third multiple access technique, which is CDMA. Now, the topics to be covered in this session, that is the introduction, features of CDMA, how does the CDMA works, advantages and disadvantages, and applications, right? So let's start with the topic, that is CDMA. Now, basically, what is does the introduction, in which in FDMA and TDMA we have discussed that the whole frequency in FDMA the whole frequency slot is divided into a different frequency slot segments, and in between guard bands are provided to substitute the limitation of adjacent channel interference. Similarly, same way like FDMA, in TDMA also the whole frequency band remains constant, but the whole frequency entire bandwidth is given to each user with respect to the different time slots, right? So at that particular time slots given, what does it happens that the user needs to work out based on the user need to work out based on the time given. So whenever the time comes of that particular user, then and then only at that particular time the user can send or receive the signals. Now in this CDMA technique, which is the recent technique going on in multiple access, the time as well as frequency remains constant, and we are dividing each users, and each users are divided with the help of each unique codes, right? So it is called as code division multiplexing. So code division multiple access, CDMA, is a digital cellular technology used for mobile communication. CDMA is the base on which access methods such as CDMA1, CDMA 2000 and WCDMA are built. So these are the different generations of CDMA, right? Now CDMA cellular systems are deemed superior to FDMA and TDMA, which is why CDMA plays a critical role in building efficient, robust and secure radio communication systems. Now, it is also very different from time and frequency multiplexing. In this system, a user has to access the whole bandwidth for the entire duration. That means the frequency and time slots remains the constant over the whole period of time. Right? The basic principle is that the CDMA codes are used to distinguish among different users. So similar to that FDMA and TDMA, here in CDMA, different codes are given as per the user request, and on that particular code the user can send or receive data to another user or another network, right? Now techniques generally used are direct sequence spread spectrum, that is DSCDMA, and frequency hopping or mixed CDMA detection. So these are the two methods for which the CDMA is working. Here a signal is generated which extends over a wide bandwidth. A code is called a spreading code is used to perform this action. Using a group of codes which are orthogonal to each other, it is possible to select a signal which is with a given code in the presence of many other signals with different orthogonal codes. So in this code division multiplexing, each and every code is differentiated and the adjacent codes are orthogonal to each other. That means there is no relation between these adjacent codes. So the adjacent channel interference limitation which was occurred in frequency division multiple access, that will overcome in CDMA. Now, CDMA is a scheme in which number of users can occupy all of the transponder bandwidth all of the time. And CDMA signals are encoded that information from an individual transmitter can be recovered by a receiving station that knows the coding being used, right? Now, next, that is each receiving station is allocated a CDMA code. So similarly, at the encoded sequence is encoded with the help of PN sequence, that is pseudo sequence, right? And that pseudo sequence is generated on the receiving side also. So at the receiving side, the receiver station can detect that the particular code is for given is allocated to particular this user. Any transmitting station that wants to send data to our station must use this correct code. Now, CDMA codes are typically 16-bit of to many thousands of bit in length, and our bits of a CDMA are called chips. Now, CDMA chip sequence modulates the data bits of original message, and chip rate is always much greater than the data rate. And this increases the speed of the digital transmission. And it is also known as spread spectrum, and two types of spread spectrum we will going to discuss in the next session, that is the direct sequence spread spectrum and the frequency hopping spread spectrum for the CDMA techniques, right, in which we use this direct sequence spread spectrum in this satellite communication. Now, as you can see in the figure, this is the figure of CDMA on the transmitting side, right? So as you can see in the figure, first figure is shown as the input bit stream with having a rate that is RB, that is bits per second, right? So as you can see, it is a graph of voltage versus time. So as you can see, for the particular time limit, it is having a code that is -1, and for particular time limit, the code is having +1. Right, so this code, right, this code is modulated for transmitting purpose. So the outgoing spread bit that is multiplied with the n number of times. So the number of bits will be n into RB. Right. So after modulation, what will happen? It will generate the codes among -1 and +1, which is shown on the right hand side of the figure. Right, and from this outgoing speed on the whenever it is transmitted, it is encoded with the help of PN sequence, which is shown in the below diagram. So again, this whole sequence is represented with the help of -1 and +1, and this in the data is in form of codes, and that is transmitted to the transmitting antenna. Now, in this, whenever we are giving the receiving side, so the signal is just demodulated, is given into a shift register, which is having a 8-bit shift register from B1 to B7, right? So all the shift register are attached with this phase shift register having a plus and minus. So depending on this plus and minus sign, this -1 and +1 will be executed. So whenever you will see at the output of the adder, V1 is passing from minus, so it is V0 that is equal to -B1, then B2 that is also passing through the negative phase shifter, the -B2, then plus B3, -B4, plus B5, plus B6, and plus B7. So output voltage will be in terms of this phase shifter, which is either a negative phase shifter or the positive phase shifter, and the whole output voltage will be the combination of this bits. Clear? So here it has been shown in the below figure. At the particular clock cycle is given from 0 to 14, and with respect to clock cycle, 1 by 1 bit is coming on the after modulating, and at the last at the 14th, this is a clock cycle, you will find that the signal which we have transmitted, that is actually getting at the receiving end. Right now, similarly, we will see this receiver side. So at the receiving side, there will be an incoming bit spectrum, so that is a transmitting side. So again, it is modulated, right? Whenever we need to receive antenna as a receiver, so that particular signal is again modulated, then this modulated signal is again transmitted back to the earth station, and the earth station will decode it with the help of this below diagram, that is called as despreading of PN spectrum. Right, so this is the actually working of CDMA at the transmitting side and at the receiving side, and meanwhile PN sequence is generated in between both the sides. Clear? Now, what are the different features of FDMA? So a CDMA, which is based on spread spectrum, that means the whole sequence is spreading over the whole bandwidth over the whole particular time, right? So what are the different features? So first, that is every channel uses the full available spectrum. That means the whole bandwidth is given to the user, each user, right, with the different codes. So many users can simultaneously use this bandwidth for the transmitting as well as receiving purpose. Individual conversions are encoded encoded with the pseudo-random digital sequence and then transmitted using a wide frequency range, right? So we are transmitting with the help of PN sequence. Then third, that is the CDMA provides battery capacity for voice and data communication, allowing subscribers to connect at any given time. And last, it is common platform for all technologies which are running right now, that is 3G, CDMA, 1X, and 4G, and 2G and 4G. Clear? So these are the various features of CDMA. Now, how does the CDMA works? So in the introduction part, we have seen the figure at the transmitting side as well as the receiving side. How does the CDMA is transmitting using this encoded PN sequence, and how this encoded sequence is detected at the receiver side and the sequence is getting back to the receiver, right? So similarly, how does here the CDMA actually works? So CDMA allows up to 61 concurrent users. So at the particular time, 61 users can occupy the same frequency, and the same codes, different codes are allocated to each user. In turn, 1.2288 megahertz channel by processing each voice packet with 2 PN codes. So each voice will or each data will have the 2 PN code, and the data will be in the between 2 PN codes. There are 64 Walsh codes available to differentiate between calls and theoretical limits. Operational limits and caller issues will reduce the maximum number of calls somewhat lower than this value. And in fact, many different signals baseband with different spreading codes can be modulated on the same carrier to allow many different users to be supported. And last, that is using different orthogonal codes, interference is minimal. Now, conversely, when signals are received from several mobile stations, the base station is capable of isolating each as they have a different orthogonal spreading code. The following figure shows the technicality of the CDA system. During propagation, we mix the signal of all the users, but by the use of the same code as the code that was used at the time of sending at the receiving side. So you can take out only the signals of each user. Now, as you can see in this figure, that how the CDMA works. So as you can see, there are two codes, right? Code A and code B. So it is code B is the sender and code A, that is the receiver. So in between this code A, whenever we need to send, right? So both the codes are given in the particular blocks is converted into the digital sequence with the help of PN sequence. Now, this whole time, during this whole time and whole frequency signals, which you can see in this figure, the whole frequency band as well as the whole time allocation is allocated, and when first it is encoded, and after it is encoded, it is spread over the whole bandwidth, and after that bandwidth is allocated at the receiver side, and the PN sequence is detected, and that particular code is allocated to either code A and code B, which is for the following purpose. Then, what are the different advantages of CDMA? So, first of all, the CDMA has a soft capacity. That means the greater number of codes, the greater number of users, right? It has the following advantages. First, that the power control, right? So, it has a tight power control, so it suffers from a near-far effect. In other words, a user near the base station transmitting with the same power will drown the signal later. Right, and all the signals must have more or less equal power, so the power required for the CDMA signals will be less. Right. Then second, rake receivers can be used to improve digital signal reception. Right, and delayed versions of time of the signal can be collected and used to make decisions at the bit level. And the transmission burst in the digital format, which reduce the interference, as the code between the adjacent channel is orthogonal, so there is no relation, so the interference will be less, right? And next, that is flexible transfer may be used. That means the mobile station can switch without changing operator, right? And two base station receives the mobile signal, and the mobile receives signal from the two base stations. Then, what are the different disadvantages of CDMA? So the code length must be carefully selected. A larger code length, so it will induce the delay and may cause the interference. Then second, the time synchronization is required between the sender and the receiver. Then gradual transfer increases as the radio may reduce the capacity. And as the sum of power received and transmitted from the base station is constant, so it will result into several handovers. And last, what are the different applications of CDMA? So CDMA is used in, first of all, that is GPS, that is Global Positioning System. Then various standards such as IS 95, that is Qualcomm, as marked as CDMA1, which are used in mobile communication, right? Similarly, CDMA 2000 is used for also over a mobile companies, right? And last, it is used for tracking the satellite for transportation logistics, right? So here we have discussed about the CDMA, how does it works, what is its transmitting side and the receiving side, right? And what are the different features, advantages and disadvantages and applications of CDMA compared to TDMA and FDMA, right? In the next session, we are going to discuss the two different techniques of CDMA, which is direct spread spectrum and frequency hopping spread spectrum, right? So that's all for today's session. Thank you for watching.